Friends, very good morning. Today's subject of discussion is the synthesis of amsacrine. The structure of amsacrine is like this, as shown here. The basic ring system present in this amsacrine is acridine. Acridine is a three-membered fused ring system with nitrogen at the 10th position. In this acridine, at the ninth position, the side chain has been attached. The side chain here is 2-methoxy 4-methyl sulfonamide benzoylene group. This is also named as AMSA, or it is also called as acridinyl anisidide, and this is used as an anti-neoplastic agent. It finds its use in the treatment of acute lymphoblastic leukemia. It inhibits topoisomerase II enzyme and hence breaks down the DNA intercalation and give its effect as a drug to treat acute lymphoblastic leukemia. Let us look into the synthesis of amsacrine. First, we have to synthesize this basic nucleus acridine and then synthesize this side chain and condense both of them to give amsacrine. As a three-membered ring system, the 9-chloroacridine can be taken as a nucleus. If the chloro group at the ninth position gets replaced by side chain, I'll get amsacrine. I can break this molecule like this. This part, what will I have? This is a phenyl group with amino group attached to it. That's why I can take aniline as a starting material. And this part, which is over here, I'll take orthochlorobenzoic acid. Now, when I heat together, this chlorine is electron withdrawing and renders this carbon positive. And there is also COH group which is also electron withdrawing, which is pulling the electrons from the benzene ring system, and hence this can react with a nucleophile. Nucleophilic substitution occurs. The lone pair of electrons from the amino group of the aniline attacks on the carbon, and chlorine being the easy leaving group gets kicked off, and the Cl minus and H plus loses HCl, and the carbon and nitrogen bond is formed. Now, this molecule, here is the carbonyl center. The carbonyl carbon is electron deficient, and this can act as an electrophile. Because of the electromeric effect, the pi electrons moves towards one carbon, giving rise to a carbon ion, which it is unstable and highly reactive, attacks on the carbonyl carbon, and it has to maintain its tetravalency, and OH gets kicked off as it is heated very strongly. The H plus and OH minus loses water molecule. Dehydration followed by cyclization occurs to give dehydrocyclized product. As these electrons have moved over here, this carbon has got positivity. To maintain its stability, the nitrogen-hydrogen bond breaks and that electrons are utilized to satisfy the positive center. And this carbonyl group, the carbon-hydrogen bond breaks and these electrons moves towards the carbonyl carbon. Pi electron, as these electrons are taken away, H becomes H plus, and this excess electrons on this carbon, as the bond is formed over here, pi electrons moves onto the oxygen, creating O minus. O minus combines with H plus, and it becomes corresponding 9-hydroxyacridine. A simple one-step process of preparation of 9-hydroxyacridine by treating aniline with orthochlorobenzoic acid. Then I can replace this OH by treating with a strong chlorinating agent like POCl3. The OH gets replaced by chlorine to give 9-chloroacridine. The 9-chloroacridine will be treated with this side chain to get amsacrine. Before that, let us look into the synthesis of this side chain. I will take 3-methoxy 4-nitroaniline and treat with methyl sulfonyl chloride. The lone pair of electrons on the nitrogen of the amino group attacks on the sulfur, the electron deficient center, as it is flanked with 3 electron withdrawing groups, 2 oxygens and 1 chlorine. Once the bond is formed between sulfur and nitrogen, it has to maintain its valency. Chloride gets kicked off and this loses as HCl, and it gives rise to corresponding methyl sulfonamide derivative. This methyl sulfonamide derivative and the nitro with nitro group at the 4th position, I reduce it using a reducing agent like iron and HCl. NO2 gets reduced to NH2. We have prepared the side chain. The side chain which is prepared is treated with the 9-chloroacridine. The amino group present on the side chain has nitrogen with lone pair of electrons. It donates its electrons to the electron deficient carbon, and the chloride gets kicked off as Cl minus. Cl minus combines with H plus and loses as HCl, and amsacrine is formed. Amsacrine is an effective anti-neoplastic agent. It is a topoisomerase 2 enzyme inhibitor, and hence it's a drug of much use for the treatment of cancer. Thus, we are interested in the synthesis of amsacrine. Next class, we will deal with other heterocyclic molecule containing drugs. Till then, have a nice day. Thank you.